All right, so one more example out of 3, 4. Remember last class, we ended last class with writing a third degree. Directions were find a, well, in this case it was fourth degree, find a fourth degree polynomial function with real coefficients that has these solutions. And when you plug in 3, you got that number. So same directions. This time we're looking for third degree polynomial. They give us the solutions of -5 and 4 plus 3i. Then when I plug 2 into the equation, I will get out 91. All right, so if it's a third degree polynomial, that means there are 3 solutions. They give us 2, -5, and 4 plus 3i. And don't forget 4 plus negative, not 4 plus negative, 4 minus 3i is a solution as well because of the complex conjugate theorem. All right, so remember what we would do. Excuse me. The way we would set this up is by putting a negative in front of our solutions when we put it back with x. Because remember, in order for us to have x equal to -5 as a solution, there had to be x plus 5 equal to 0. So when I subtract 5 from both sides, then I will get my solution. So we're going to do x minus -5, x minus 4 plus 3i, and x minus 4 minus 3i. So that's how you would set it up. And don't forget, a is going to sit in front of that. Remember, we need to put an a in front to give an account for a possible term or possible number that's sitting in front. Now, negative to negative turns positive here. Then we'll distribute this negative and distribute this negative. All right. That will give us this result right here after we distribute our negatives. Then from there, it will be best that you multiply these two together because you have the imaginaries that you need to cancel out some terms. They're going to cancel out because they're multiplying conjugates. So you take that x, distribute it to each term, take the -4, do the same, and take the -3i and distribute as well. All right, when you distribute, you're going to have x squared minus 4x plus 3xi minus 4x plus 16 minus 12i minus 3xi plus 12i minus 9i squared. So once you do this multiplication and distribution, all of your terms that have I involved should be either cancel out or simplify out one way or the other, just like I squared is -1. So once you simplify that, you will no longer have the imaginary part. So 12i is going to cancel. 3xi is going to cancel as well. And also mention that I squared will turn to -1. 4x plus negative 4x and negative 4x give you 8x. So you combine all your like terms as well. So that leaves us with this expression. So after everything cancels and simplifies, you have x squared minus 8x minus 16, and then negative 9 and negative 1 gives you a positive 9 right there. From there, now we can go ahead and multiply these two expressions. We're going to distribute, and I didn't mention, oh yeah, I didn't mention right here. Sorry about that, I didn't mention right here that we add 16 and 19 together to get that 25 right there. 16 and 9, excuse me, not 16 and 19, 16 and 9 together to get the 25. And so now we'll FOIL out or distribute out the x plus 5 into x squared minus 8x plus 25. So once you do so, you have x squared minus 8x squared, x cubed minus 8x squared plus 25x plus 5x squared minus 40x plus 125. Combine your like terms, that'll be x cubed minus 3x squared minus 15x plus 125. Any questions? All right, so we simplified our expression as much as possible with this right here. So now we need to figure out what happens when I plug in negative 2. All right, so plug in negative 2. That's 2 cubed minus 3 times 2 squared minus 15 times 2 plus 125. And we're supposed to have it equal, out to 91. So that's 8 minus 3 times 4 minus 30 plus 125. Reduce that all the way down. That'll be 91. So solve for a, you would divide both sides by 91, and a is just equal to 1. All right, so you will put a equal to 1 right there. And of course, 1 times anything is itself. So that's our final answer. All right, any questions? Any questions? Make sure we're good. All right. Everybody good to go to 3.5? Okay. So 3.5, rational functions and their graphs. So we're going to look mostly into asymptotes. We're talking about 3.5. So asymptotes are going to be places where the function is undefined or does not exist. or places where the graph do not cross. All right, we have three types of asymptotes. Vertical asymptotes, horizontal asymptotes, and slant or oblique asymptotes. Slant and oblique asymptotes are the same thing. So we're going to explore how to find each one of those. So vertical asymptotes is where the denominator is equal to 0. So the first thing you want to do is simplify as much as possible. Simplify your equation or expression as much as possible. Set the denominator equal to 0, and then solve. All right, if I'm scrolling up too fast, let me know. So first one says find the vertical asymptote, if any. And so your asymptotes, when you go to graph and you ever see those graphs when you have that imaginary line, where in these graphs, they don't touch or go across, but there's something there that's stopping them from doing that. So those are your asymptotes. So here, didn't mean to do that. Here we'll take x squared minus 9, set it equal to 0, and then solve it. So that's what we're doing over here. X squared minus 9 factors out to give you x minus 3x plus 3. Set each part equal to 0. And you get x equal to negative 3 and x equal to positive 3. So you have two vertical asymptotes, one at each equal to negative 3 and one at positive 3. Any problems? All right, everybody good with A? All right, so the next one, looking at B. We have x plus 3 over x squared minus 9. So remember, the first thing I said we should do is simplify as much as possible. So that's what we did here. We factor out the denominator, x plus 3, x minus 3. And x plus 3 cancels and leave you with 1 over x minus 3. All right. All right, so After you cancel out this x minus 3 right here, will produce your vertical asymptote. All right. And but we cannot forget about what was there in the original problem, which is x plus 3. So this x plus 3 will produce a restricted value. So that wouldn't be a vertical asymptote. That x plus 3 would be a restricted value. So in our original problem, our graph would go in that direction, but there would be like a circle there, or just a spot where it would not exist, but it would not produce an actual asymptote wherein the whole line would, go up like we saw in the last example. So this is how you would look at that. You'll have vertical asymptote at x equal to 3, but a restricted value, a place where the graph doesn't exist at x plus 3. Will it be x equal to negative 3, excuse me. Any questions? All right, next one. X plus 3 over x squared plus 9. So you cannot factor that. But if we were to set it equal to 0 and solve, we see that we will get imaginary numbers. And since they are imaginary, that means we do not have any vertical asymptotes there. All right. Any problems with A, B, or C? All right. And let's see what's going on. Somebody must have asked me a question about something right here, but that doesn't have anything to do with our problem. All right, any questions before we go to horizontal asymptote? All right, so let's look at horizontal asymptotes. When we go in here, we're going to let n be the degree of the numerator, and m is going to be the degree of the denominator. So when we say the degree of the numerator, we're talking about the highest exponent in the numerator, and the degree of the denominator will be the highest exponent of the variable in your denominator. So highest exponent of the variable in your numerator, highest exponent of the variable in your denominator. So for the first one, first condition, if n is less than m, then your horizontal asymptote is y equal to 0. All right. If your exponents are equal, then y is going to be equal to the leading coefficient of the numerator over the leading coefficient of the denominator. And also let me point out before we keep going, when we go to our our vertical asymptotes, remember that, always keep in mind that was x equals, that's a part of it. You don't just write 3, you write x equal to 3. And then here, now that we're dealing with horizontals, we're looking at y equal to. So just pointing that out. All right. And then if n is greater than m, there is no horizontal asymptote. And notice that means we're actually going to go to your slant asymptotes. right, so those are the three conditions for horizontal asymptote that you guys copy it. All right, any questions before we try this out? All right, find horizontal asymptotes if there is one. Find horizontal asymptote if there is one. Yep. All right. So the first one, f of x is equal to 4x over 2x squared plus 1. So the exponent for our numerator, or the degree of our numerator, is 1. Degree of the denominator is 2. And remember, we said the numerator is considered n, denominator is considered m. So since n is less than m, your horizontal asymptote is equal to 0. So y equal to 0. All right, make sure we're okay. All right, next one. Degree of the numerator and denominator is 2. So that means our variables are equal. So what we'll do is take the coefficient of each x squared, or the leading coefficient of each numerator and the denominator, place them over each other. So that's 4 over 2, and y is equal to 2. So once again, when your numerator's degree is less than the denominator's degree, y is equal to 0. If they are equal, then y is equal to the leading coefficient of the numerator over the leading coefficient of the denominator. And for the third scenario, we have 4x cubed over 2x squared plus 1. Our leading coefficient, or not leading coefficient, leading degree, or the degree of our numerator is 3. Degree of the denominator is 2. So this time n is greater than m. So that means we do not have a horizontal asymptote. Any questions? All right. Third one, slant asymptotes. When n is greater than m, write that a little better. There should be is slant asymptote. All right, so we use long division or synthetic division. You know, it depends on if we can to find it. And so it'll be on the form of y equal to the quotient. So whatever that, you know, when you set up your long division and you have something out here, have something in here, this answer part will be your slant asymptote. All right. All right, can I scroll up? Are you okay? All right. So here, let's look at one. We have find the slant asymptote. They give us x squared minus 4x minus 5 over x minus 3. And because this is the way this is set up, we can use synthetic division. I can write this thing. All right, so x minus 3, I went ahead and used synthetic division. You know, remember the way we would do that? You know, if you want to walk through the process, remember you have your coefficients of 1, -4, and -5, which are right here. Use the opposite number of this, opposite sign of this. That's why we have positive 3 here. You start by bringing down your 1, and 3 times 1 is 3 that goes here. Add those together. That would be -1. 3 times -1 is -3. Add those, and that'll be -8. So you go down here, start with 1 degree less than what you had, or 1 exponent less than what you had. So that'll be x to the first power minus 1 plus -8 over x minus 3. That's your remainder. And so the x minus 1 is your slant asymptote. All right. Everybody all right before we look at another one? All right, so next one, x squared plus 1 over x minus 1. So once again, I decided to use synthetic division because I could, looking at x minus 1. And don't forget we have a missing term here. You have to give an account for that. And that's the x term. So I have 1, 0, and 1 as my coefficients. Maybe talking about walking through it. Bring down 1, 1 times 1 is 1. Let's put that up here. Add those together. That's 1. 1 times 1 is 1. Add those together, and that'll be 2. So that comes down here. Started off with x squared. So my answer will start off with x to the first. So it's x plus 1 plus 2 over x minus 1. And my horizontal asymptote, my slant asymptote, excuse me, is y equal to x plus 1. All right, any questions? Make sure we're okay. I think that's it for this section. Yep. All right, any problems before we look at the next section, at least start the next section? All right, can I come off this page? Everybody okay? All right. So 3.6, polynomial and rational inequalities. So we're going to look at quadratic inequalities first. Where in our quadratic equation or quadratic expression always produces a parabola. And it's either going to be, an upward U, concave up, or it's going to concave down. All right, either concave up or concave down. So if it concaves up, notice that you have these intervals. Right here is where the graph is going to be equal to 0 at these points. So above and below those points, you have your interval or your graph responding a certain way. So above it, that's positive, and below is negative. Same thing with the next one. Anytime it's above those points, it's positive. Anytime it's below, it's negative. So all of your values respond in that way within those intervals. All right. So that's going to matter when we go to actually solving. Everybody okay with that? Okay. So we have 2x squared plus x greater than 15. So first thing we want to do is set one side equal to 0 because we want to make a clean comparison. All right, so we'll minus 15 from both sides. And that's 2x squared plus x minus 15 greater than 0. So we want to know, when is 2x squared plus x minus 15 positive? We want to know, when is that left side greater than 0? Remember, greater than 0 is positive, less than 0 is negative. So when you say greater than 0, that's mathematical. The mathematical way of saying positive. When is this expression positive? All right. So next thing we're going to do is solve for when it is equal to 0, because we need to figure out where those dots are, those points that I pointed out in the graph. We want to know, when is our expression equal to 0. Then we'll be able to evaluate when it's greater than or less than 0. So I went ahead and factored this out. Got 2x minus 5 times x plus 3. Now, once again, if you're not comfortable with factoring, or if you can't see the factorization, remember you can always use the quadratic formula, which will give you these same values. So I end up getting x equal to 5 over 2 and x equal to negative 3 as solutions. In other words, this is when the equation is equal to 0 at these 2 points. All right. Scroll up. Okay. So what this does is it sets up our intervals for us. If we look at our number line, our graph is going to behave one or two ways. It's going to be positive or negative, and it's going to alternate when you're talking about your quadratic equation. Now, you can never assume that it's going to alternate once you start doing this stuff in general, especially when you get into calculus. Upon a certain interval, it may not alternate, and that will be, saying a reason for why you would do certain things. So when you get into calculus, it may not flow like that. But when you're talking about just regular quadratic functions, it should alternate plus minus plus or minus plus minus. So we have this first interval of negative infinity to negative 3. Then we have this second interval, negative 3 to 5 over 2. And then the final interval, 5 over 2 to infinity. So we're going to set up our chart that way. And let me erase some of this stuff so we can walk through it. All right. So you want to set up this chart to help you figure out what the answer would be for you. All right. So like I mentioned, first interval is negative infinity to negative 3. Second interval, negative 3 to 5 over 2. Then the third interval, 5 over 2 to positive infinity. All right. So now we note on our infinity signs, we always use parentheses. But when it comes to negative 3 and 5 over 2, you go back to your original problem. Notice right here we have the greater than symbol. So that means we're going to use parentheses on them as well. Now, if it's greater than or equal to, we would use bracket. Remember, we talked about the distinction between using parentheses versus using a bracket. So these would use parentheses. And now we need test values for each interval because your graph is going to behave the same way in each one of those intervals. Either it's going to all be positive or they're all going to be negative when you plug in your values. So you can use anything as test values as long as it's in the interval. So anything less than negative 3, I can use negative 4. Anything in between negative 3 and 0, negative 3 and 5 over 2, I can use 0. And then over 5 over 2 to positive infinity, we can use positive 4. Really, you can use 100, you can use 1 million. Same thing with just negative 4. I could use negative 1,000 if I wanted to. As long as it's in that interval, it's still going to give me the same type of result. In other words, look at this last row. The behavior is still going to behave the same way. Either it's going to be positive or it's going to be negative. That's an outcome. So you plug in those test values, and I plug it into my factored state, just an easier way for me to get my answers. So plug in negative 4 where x is. 2 times negative 4 minus 5, and then negative 4 plus 3. So notice what I did right here. I didn't put any numbers because I don't need the numbers. I just need to know, is it going to be positive or negative? So these numbers could be anything for you. You just want to know, are you going to get a positive or negative result? And so when you do that work, you get negative times negative from each parenthesis. So that would be positive. Plug in 0. That'll be negative 5 times positive 3. So negative times positive, which would be a negative. And then plug in positive 4. Should get positive times positive, which is positive. All right. Make sure we're okay with what we got. So once you have filled out the chart, now you need to go back and make sure you remember what it is that they asked of you. They want to know, when is it positive? So they want to know, when is it positive? So notice it's positive right here and right here. So those would be your answers. And that's what we have right here. All right. If they wanted to know when it was negative, then all you would have done was give that middle interval. -3 to 5/2. Any questions? Any questions? All right. I'll scroll up. Is everybody okay? All right. So the next one, x cubed plus x squared less than or equal to 4x plus 4. So remember the first move, so you want to set one side equal to 0. So I subtracted 4x and subtracted 4 from both sides. And it gives me x cubed plus x squared minus 4x minus 4 less than or equal to 0. All right. So I want to go ahead and set it equal to 0 to solve. Remember, we're looking at when we want to know when is it negative, because it's less, I can't even get it out, less than or equal to 0. So we want to know when is it negative. Remember, before we talked about being greater than 0, so that's trying to figure out when it's positive. So I went ahead and factored this out. 4 more terms mean you can factor them by grouping. So I grouped together the first 2 terms and the second 2 terms. Don't forget this minus sign needs to be included inside that parentheses right there with the 4x. Factored out x squared. Then I factored out -4. The x plus 1 I brought to the front, and that leaves me with x squared minus 4. X squared minus 4 is the difference of squares, and that gives me x plus 2x minus 2. So I factored that out completely. All right. So each part equal to 0. It gives me my intervals, my solutions. All right, any problems, any problems? All right, so just like before, it helps us set up our intervals. And let me erase this chart stuff and talk about it. So you can see right here, our first interval is -∞ to -2, -2 to -1, -1 to 2, and then 2 to positive infinity. So that's what I have set up in the chart for my intervals. All right. So set up my chart the same way. Got my intervals. We need our test values, and then we need the behavior of the graph in those intervals. So once again, your parentheses will always have infinity signs. This time, because our function has greater than, less than or equal to That's why I pointed out right here. We're going to use brackets on our numbers. So all right. So now we need test values. -3 here, -1.5, do 0, and +3. Let's see if I held true to those same values. Yep, okay, just making sure. Cool. All right, so you can choose any number in those intervals. They'll still give you the same result. We want to know, am I getting a positive or a negative number out? Doesn't matter what number I get, but is it positive or negative? Because if it's negative, it's less than 0. If it's positive, it's greater than 0. All right, so once again, I plug it into my factored form, my expression. If you just want to plug it into the regular expression, that's fine. You know, as long as you get the result, then you're okay. So plugging in -3 ends up giving me a negative times a negative times a negative, which is just negative. Plugging in -1.5 ends up giving me a negative times a positive number times a negative number, which will give me positive. Plug in 0, get +1 times +2 times -2, which would be negative. Then plugging in 3 for the last one, positive times positive times positive will give me a positive result. Any questions? Any questions? All right. So go back to your answer. You want to know when is that expression less than 0? So you're talking about, oh, not that one. These two intervals right here. Once again, it's not always going to be multiple intervals. Sometimes it may just be one. It just depends on what's going on in the problem. But in this case, we have -∞ to -2 and -1 to 2 as our answer, our solution set. All right. Any questions? Any questions? Make sure we're okay. Everybody good? Everybody straight? All right. So next we have rational inequalities. Let me see what 370 is. Direct variation. Yeah. So I think this is a good place to pause since we had 3, 4, did 3, 5. So we'll pick up right here on next class, do a couple of problems out of rational inequalities. Then we'll do 3, 7, and we'll be done with chapter 3. Because I'm not going to go into 4 next class. You know, jump from 3 to 4. So we'll do, like I said, we'll finish off this section, and then we'll do 3.7. And then we'll talk about how we're going to flow, you know, before we go into chapter 4. All right. Any questions or concerns before we close out? Everybody good? All right. So you guys have a good one. Be safe and have a great weekend. And I'll see you on Monday.
Thank you.
Thank you. Have a good one.